Okay, so here we are. I'm looking at the Quizizz quiz called Sequences, Convergence, or Divergence. And there were 5 questions, I don't remember. We'll see. That I wanted to go over kind of quickly here. First was number 1, where some of you did have some trouble. And the question is, what about this sequence? A sub n is equal to the cosine of n over 2. Does it converge or diverge? And the question really is, what's going on here with n over 2? As n approaches infinity, because that's what we need to look at, the n over 2 for cosine, well, its argument is just getting larger and larger and larger. And since cosine is a periodic function, that just means you're going to be looking at the cosine curve as it just keeps going, wiggling up and down and up and down, doing the best I can here, forever. And so the value of cosine n over 2, it just keeps going up and down and up and down, and it never settles into anything, and it's going to diverge. If it doesn't converge to a specific limit, it diverges. So the answer there would have been A, diverges. Let's take a look at number 2. Number 2, it looks very similar, but the difference here is now we're talking about cosine of 2 over n. So what happens to 2 over n as n gets really large? Well, it gets really small. In fact, the 2 over n in here, it's shrinking to 0. And the cosine of 0 is 1, and that's the convergence for this particular sequence. As you look further and further out at the terms, check it with your calculator. 2 over 10, 2 over 100, 2 over 1,000. Those cosine values, they're approaching 1. Let's take a look at number 7. This one was a little more difficult because now what you really have to look at is the limit. Oh, got it over here. The limit as n approaches infinity of n sine 8 over n. Well, let's look at these pieces. N, it just gets larger and larger and larger. It's approaching infinity. 8 over n, it's approaching 0, like we just saw in that cosine problem. And the sine of 0 is 0. So what you have in this limit is an infinity times 0. And way back when we studied L'Hopital's, this was a variation of L'Hopital's. Infinity times 0 can be algebraically changed to become a L'Hopital's acceptable form. What we need to do here, and I think the easiest way, is take this n. Oh, come on, little yellow dot. There we go. Take this n, and we're going to move it to the denominator. Now, an n in the numerator becomes, that didn't work. There we go. Becomes a 1 over n in the denominator. Think back, if you took divided by 1 over n, flip it, multiply, that becomes this n. So now we're dealing with a 0 sine of 8 over n, and 1 over infinity also 0. We now have 0 over 0. This is a L'Hopital's case directly. Go back, take the derivative of the numerator, derivative of the denominator, and you will end up with one of those answers over there. In fact, you should end up at 8. You can go back and check that. Number 8, my apologies for giving you that problem. This one leads to a 1 raised to the infinity, which is another version of L'Hopital. We didn't cover it. You don't need to know how to handle it. I should have deleted the question, and I apologize. And let's look at number 9. Number 9 uses a log rule. You have natural log minus another natural log. The rule is that becomes the natural log of a quotient. So there's your quotient. Well, the nice thing about this quotient is that as n approaches infinity, highest degree over highest degree, 1 over 1, this becomes a 1. And the natural log of 1 is where this is headed. The further out you go, n gets bigger. That natural log approaches natural log of 1, which is 0. So this one also converges. And hopefully that takes care of the biggest issues out of that quiz. This little video was prompted by someone emailing me with a question. So feel free to do that as you're working through stuff, and I'll see what I can do to get some answers out there. All right, for now, thank you.